This conference will now be recorded.
Okay, sorry, guys, I was speaking good. Fine. So let me get started. So last week I was giving you the overview on various topics which we are going to learn in this performance engineering uh, sessions, right? So last week I covered all these topics and I also explained you a couple of things from a Java basics perspective. We try to learn what is the skeleton of any Java program, what is method, what is object, what is class. We also the data types, primitive data type, non-primitive data type, and also we went into Eclipse and then created a few programs, few methods, and we try to call one method from another class file, and we compiled, we executed. More in the objective of for us to get a comfortable with these terminologies, these environment, right? We're not going to be a development. We are not going to develop any applications. Rather, when we go and talk to the developers today as a performance tester, you go and report response time problem or transaction failures, right? Now once you are going to be a performance engineer, you're going to go and report saying that there is a problem with your class file, there's a problem with your method is having high response time. You're going to say that there is a problem with your object where there is a leak. So you're going to talk about, you're going to report about, complain about their methods, object, and classes. Correct. So you should not be a black box for you when you go and talk to them. So that's the intention of having these basics of Java and JVM. Right? Hope you guys have got some time to go and install these softwares and try some programs by yourself. If not, please do it so today or tomorrow as well. Okay, it's very important, not mandatory, but it is good to do it, right? Just getting an hands-on these things will help you to get that extra level of confidence. Okay, and we are not asking you to go and learn Java or learn coding. No, just create a boiler templates, right? Just create a project, create a class file, copy paste the whatever the program I given in the drive. Just download it, copy paste it, run it. So you will be able to visualize it, what a program is going to be, what a class is going to be, what is a package. A package will consist of multiple classes. A class will consist of multiple methods. How to call one method from another method. Because when you go into do a engineering analysis, right, in the AppDynamics or Dynatrace or JProfiler, when you go into root cause analysis, all these tools are going to give you the root cause in a way that, okay, the problem is there in this particular package, in this particular class file. From this class file, another class file is called. That is where the I response time is taken. From there, API call is called. That is where the I response time has been considered consumed. Those kind of a hierarchical view is what you're going to get it in the AppDynamics or JProfiler. So from that perspective, it is important for you to learn these terminologies and learn the structure of the programs. Okay, so today what we will do is we will look into the um, JVM basics. Okay, again, JVM basics is important because um, whatever that is going to get executed, I was telling you last week about JDK, JRE, JVM, right? Your Java application is going to get executed in a JVM, right? Whatever the code you develop, whatever application you develop, it is going to get executed by a Java virtual machine, right? So which means Java virtual machine is going to take care of your memory allocation. It is going to take care of your threads. It is going to take care of your CPU consumption. Everything will be part of your JVM. It's a and when we do profiling, when you do analysis, when you do heap dump, thread dump, all these things will be around this JVM. So it is important to learn this JVM basics as well. Okay. So let me go to this. Okay. Before I'm going into this, anybody have any questions, clarifications on the session topics, what you're going to learn? Any doubts from last week's session? Anybody have any such questions, doubts? Okay, no problem. Okay, so when it comes to JVM, right? Uh, JVM is going to consist of uh, three layers. Okay, one is your class loader, second is going to be your memory, third is going to be your execution engine. Okay, just give me 1 second. Sorry, guys. So yeah, so there are three major components in JVM, right? One is your class loader, second is your memory, third is your execution engine. Okay? So all the classes that you create, right? Um, Part of your own application, it could be external classes and the native classes. Uh, it has to get loaded when JVM starts. All the classes has to get loaded into your JVM. Okay, so the class loader will take care of loading all your classes, which doesn't uh, important from a performance engineering perspective. So we don't really care about the class loader at all. Okay, it's just a component in JVM which is going to take care of loading all the classes. That's it. From a definition perspective, from engineering, performance engineering, it doesn't play any role from our point of view. Okay, JV memory is a main important um, component. In JV memory, there are 5 subdivisions. Okay, your there's something called metaspace, heap, JVM stacks, PC register, and native stacks. Okay, out of these 5 components, um, 2 components are relatively very important: heap and JVM stack. And when comparing these two things, heap is a major component from an engineering perspective. From a performance perspective, we are going to profile, we are going to configure, we are going to monitor, we are going to analyze. There will be a lot of problems within the heap. So heap is a very important component within the JVM memory. Okay, I'll explain what is these things. So heap and stack. Okay, I was talking about primitive and non-primitive last week, right? Your integer, character, boolean, all small variables which is going to occupy a small memory space. They are going to get stored in the stack. Okay, and the objects, your strings, arrays, everything is going to get stored in the your heap. Okay, so whatever you declare in your program, right? Whatever you want to declare in a program, it has to get stored somewhere, right? Because everything is going to occupy some kind of memory, 1 KB, 2 KB, 5 KB, whatever it is. So within one class file, within multiple class file, multiple variable declaration will be there. It has to get stored in the memory, correct? So in JV memory, logically they are partitioned into 5 smaller components, like your metaspace, heap, stacks, register, and native stacks. In that, heap and stack are the relatively very important component. The reason is whatever that you declare in the program is going to go and sit in the heap and stack. The strings, arrays, objects which are huge in memory space, it's going to go and stored in the your heap. Small variables like integer, boolean, character are going to get stored in the your stacks. Okay. So when you compare the stack and heap, the stack is something, again, it's not going to be a problematic at all. Since it's going to be very small things are going to get stored, and when a method is completed, right, when a method is getting completed, immediately your all this integer boolean will get removed immediately. So there is really will not have a major problem with the stack. We will not monitor the stack. We will not configure the stack. We will not profile the stack. So nothing, there's no major contention will be with the stacks. There will be one problem from a batch application perspective, which I will tell you later when we go into the memory section later. But stack is something we will really don't, we will not go and configure. It's a heap, right? If you have done it already, let me go to um, the e-library application which we are going to use for our session. In that, if you go to the one of the configuration file, we'll go and configure the heap. I need 2 GB, I need 1 GB, I need 500 MB. We'll go and configure the heap. Okay, but stack or other things, we never really go and worry about it, or will not even go and configure it. Okay, I'll open this catalina.bat file. Okay, if you see here, there's something called XMS, XMX. Okay, we'll go and configure the minimum heap and maximum heap. What to configure, when to configure, and all, we will learn detail during the JVM benchmarking. But what you need to know is, out of these 5 components, heap is the one which we'll go and configure, which will go and tune, which will go and profile, will monitor, we will analyze. Everything will happen around heap. Stack is something hardly we do anything at all. Okay, there's one Stack Overflow exception, Stack Overflow error. If you have seen this website called Stack Overflow error, uh, that comes from this particular component, Stack Overflow error. Okay, there's a blog called Stack Overflow where a lot of Java related information, Java related questions will be answered in the website. Stack Overflow. Okay, so heap, we will learn a lot about heap in the upcoming sessions, but from a definition perspective, this is what you need to know to get started with this. Okay, stack is going to store integer, character, and boolean kind of a data type, and heap is going to store your strings, arrays, and objects. Okay, and then the metaspace is going to hold the metadata about your classes. It is going to store information about your class files. It is going to store all the static variables in your entire application. If you declare something as a static, right, static variable, that static variable will go and sit in the metaspace. That's it. Again, metaspace, we are not going to mostly touch it. We are not going to configure. We are not going to monitor. We're not going to allocate any memory to metaspace. Automatically, your JVM will allocate some memory from your RAM. Okay. See, by default, stack will get a memory of 1 MB. Okay. Metaspace, JVM will allocate memory from your RAM. PC register and native stacks also, your JVM will allocate some memory from the your RAM by default. We no need to worry about at all. Only heap alone, we need to go and configure it in the Catalina file, or in other servers it can be other configuration file as well, right? But basically we have to configure the heap. This is the only component which we will configure. Okay. Other 2 components are not much of importance. PC register, by definition, it will keep the recording of, or it is like an index. Okay, it will store what methods are getting executed, what lines of code is getting executed. It is more of a registry, what threads are is executing what. That information is something, it will be there in the PC register, very temporary storage. Okay, native method stackers, whenever your Java application is going to interact with your your Windows OS or with any other your Windows based application or Linux based application outside of your application, right? To store those kind of references, there is something called native stacks. So let's not worry about and get confused. Uh, all these 5 components from a definition perspective, we just try to understand. Heap and stack, we will learn a lot when we go into the memory profiling session sometime next week. We will go in detail about the heap and stack. Okay, because there's much more importance when it comes to garbage collection and all. Again, relationship between stack and heap is very, very important. And the third component is going to be your execution engine. Okay, execution engine is going to take care of the actual execution of your code. In execution engine, there are 3 components. Okay, one is your interpreter. Interpreter is going to convert your bytecode into your machine understandable code. Okay, see, when you compile your code, okay, and you deploy it, it is going to be in a some format called bytecode. Okay, that's a Java format, a compiled version of the Java. But your Windows or Linux or Mac OS or Android might not understand that bytecode, right? So for when it gets executed, right, this component interpreter will convert your bytecode into a OS understandable code. That's a job of the interpreter. Again, we no need to worry about this interpreter from engineering perspective. We just need to just understand it. The hotspot profiler and JIT compiler are it is related to the performance, but we don't have a control. We or architects will not have a control. The way it will work is the hotspot profiler and JIT compiler. Hotspot profiler will keep looking into all the frequently used methods, frequently used classes, and it will um, mark it for a JIT compiler to pre-compile it. So instead of, see, interpreter will take some time. Okay, whenever it's going to convert bytecode into a machine understandable code, it will take some microseconds or maybe a milliseconds. To avoid that milliseconds or microseconds, hotspot profiler will spot the methods class which are frequently called, and JIT compiler will pre-compile and keep it ready so that uh, those methods will not get converted into a bytecode during a runtime. Okay, so this is related to a performance, but it's not something in our hand, right? We are not going to choose the profilers or choose the configure it or tune it. No, it's a by default your JVM is going to have this component for pre-compilation. The last one is the garbage collection. Okay, garbage collection is an algorithm, as a component within execution engine, which is going to take care of cleaning your objects, cleaning your unused, unreferenced object. Okay, by nature, the strings, arrays, object, whichever that is going to sit in the heap, will not get deleted immediately. The things that are getting stored in the stack will get deleted immediately. Okay, nobody need to do anything at all. Once that method is completed, in that method, you might have declared one integer, one character, one boolean. Everything will get deleted immediately once method is over. But when you declare a string or an array, or when you initialize an object, those will not get deleted immediately, even when when a method is completed. Okay, it will sit in the heap. So garbage collection is an algorithm. It's a software component which is going to take care of deleting these objects or the arrays, strings. How, when, uh, those things we will learn later when we go into the garbage collection sessions. We'll learn about GC logs, minor GC, major GC, various components in your GC, when the GC will get triggered, what is compacting, what is deletion, what is marking. All these things we will learn in detail when we go into the garbage collection session later. Okay. So when you the way it works is, so you create your .java, which is in your Eclipse, and then when you compile it, it will get converted into a class file, and then that could be one class file, two class file, three class file. all these class files, you create a jar or a war, right? It is kind of a archiving, or it kind of a zipping. You combine all your packages, classes, everything into a bundle, right? You either bundle it as a jar or you bundle it as a war, right? And this jar or war will get deployed in the your Tomcat or JBoss or any other WebLogic kind of a server. Okay, so that when it is getting deployed, and then when Tomcat starts, your JVM will load all the classes, and then it will load all the system library class files through this class loader. And then when the application is getting invoked, when somebody is going to call login, or when they're going to call the registration or other transactions, it is going to call the corresponding class files, and the variables are going to get stored in the stack heap. The code is going to get executed, and this cycle will continue. So that's the entire life cycle of your from the compilation to converting to a jar or war. And then when Tomcat starts, it will get loaded through class loader, and somebody is going to access your application. The corresponding variables will get stored in the memory, and then the code will get executed through execution engine, and this cycle continues until your JVM is going to stop. Okay, I'll take a pass here, guys. Anybody have any questions? Okay, some of you have asked. I have given a video how to set up this Tomcat and the e-library application as well. I don't know whether you have looked into the video or not, but a few people pinged saying that they couldn't able to understand. Let me repeat that. Okay, so if you go to the drive, I'll ping the Google Drive as well here, the drive link. Okay, second. I'll ping you this drive link. You guys please check whether you have access. Okay, so once you go to this drive, okay, you will have a Tomcat folder here. Okay, something called Tomcat new t.zip, the last one. Okay, this one. Download it. Okay, download and unzip it. Okay, so you'll get this folders. Okay, and then what you do is you go to the web apps folder. Okay, you need to download a war file from the drive as well. Okay, if you go here, you will find something called e-library war. Okay, in that, download this without db. This particular .war file, download it. Okay, in the e-library war folder, download this. Once downloaded, you copy to the web apps folder. Okay, and then rename that to e-library.war, like this. E caps, L caps. Make sure that E caps, L caps, e-library.war. Okay, once it is done, okay, go to the bin folder. Okay, right click this, uh, catalina.bat file, go here. Okay, and then just go to this line number 115 or 116. You can leave this as it is. Okay. In the next 10 lines, wherever you see there's a drive, D drive or C drive, right? Those lines you comment it out. Comment instance put REM. When you put REM, it will get commented. In the next 10 lines, like up to this, wherever you see there is a C drive or D drive, comment it. Other things you can leave it as it is. All these configuration and all you can leave it as it is. I'll tell you what is this later. Okay, and then save it, and then go to the command prompt, use cmd command prompt, and then type java, no sorry, type startup.bat. Okay, so your Tomcat will get opened, and then it will deploy the war file. Before that, make sure that your laptop is having a Java. Okay, Java 8 or Java 11, whatever it is. It will take some time to deploy. I have AppDynamics as well connected. I'll tell you later how to connect AppDynamics cloud with e-library application as well. Since I have AppDynamics connected, it says that started AppDynamics Java agent successfully. Okay, so let it start. I'll go to the AppDynamics as well meanwhile. Okay, AppDynamics, I'll tell you later how to set up your own AppDynamics account for yourself. It's a trial version. You can set up your own AppDynamics in the cloud, and you can connect that AppDynamics with the e-library application. So that when you run a load test from Jmeter, you would be able to go and monitor your application, monitor your GC, monitor your EP utilization, thread utilization. You can look into the root cause of a response time issue. All these things you would be able to do it. We'll learn those things as we go into those particular sessions. Let me log in. Meanwhile, yeah, it is, I think it is deployed. Yeah, it is deployed. Right. So let me go into the Chrome and then go open the localhost. So once you see this message saying that the server is started, right? Then go to your Chrome and then type in localhost 8083 library. And also just to verify, right? Go to your Tomcat and then go to the web apps. That should be a folder created called e-library. And if you go into the e-library, you will see all these files, which means your deployment is successful. Okay, so then go here. Default login is admin@jtp.com and admin123. Admin123. Let me check my the email ID for this AppDynamics. Just give me 1 second. Meanwhile, this is logged in, right? So this is logged in. So, and there is a view librarian, add librarian, all these functionalities are there for you to use it. So during your profiling, during your other engineering sessions, we'll use this sample application, not a sample application, this real-time application for our hands-on. I haven't started the DB, that's why it gives an empty table for view librarian. Let me start the MySQL. Okay. You no need to worry about these MySQL setup and all for now. Even for that, I have a video to set up the MySQL database, or I will tell you tomorrow or next week how to set up the SQL DB in the class itself. For now, SQL DB is not required for we will for at least for a login. You no need. So when you start the engineering session, we will get started with the login only when it comes to response time analysis, and then we'll move to the other transactions for which we need a DB. So I'll tell you how to set up the DB later. Okay, you no need to worry about it for now. Satish.satish123 at mfs dot Isha Training Solutions.org. Now, if you go to vLibrarian, it should provide the all the librarian names. Yeah, all these things are getting listed. So with this email ID and password, I should be able to log in as a librarian as well. I can log in as a librarian, then I can be able to go and look into add book, view book, written book. There are many more such transactions available in the application. Okay, so this is the application which we'll be using it for our engineering. So this is my own AppDynamics trial version, right? So for you, you can also set up your own AppDynamics so that this application you will be able to monitor it in the AppDynamics, and we'd also be able to do a diagnostics, heap and GC monitoring. All these things you can do it by yourself in the AppDynamics. Okay. Yeah, this is a setup you need to do it, right? This is a setup you have to do it from in your mission. Very simple. Have your Java, have your Tomcat, and then copy the war file, start the war file. Start your Tomcat. 5-10 minutes, not more than that. If anybody have any problem while starting the Tomcat, there might be some issue, some error. It will come. It's very common. Whenever you deploy, whenever you do first time in a mission, you will get to see some interesting errors, issues, but it is all something we'll be able to solve it very easily. So spend some time today or tomorrow and complete this hands-on at least, so that you will be able to practice it, all the things that we are going to learn from tomorrow. Okay, I'll pass it here, guys. As I said, I don't want to have a longer session today since less attendance because of the festival today. Anybody have any questions from today or any other from a topic perspective? Anybody have any questions? Okay, if you guys don't have any questions, we will stop it here, and tomorrow we'll connect and then continue with the other topics. So tomorrow what we will do is we'll get started with the response time analysis. Okay, so for the login transaction, assuming that you are going to be in a project as a performance engineer, e-library application is getting developed. So we our objective from early engineering is, as the application is getting developed, as the functionality is getting developed and deployed, we'll go and look for uh, your response time and the memory utilization for one transaction for single user. That is the shift left, or that's a performance engineering early performance engineering that we have to do it. So every functionality, new functionality, we have to take it and profile it to understand how the response time is, whether the response time is good or bad. If it is not good, then we have to go and do a CPU profiling to find out the hotspot. Same thing for memory as well. So we'll get started with this response time analysis right away from tomorrow. Okay, I'll stop it here, guys. We'll continue tomorrow. Yeah, thank you.